We are going to discuss methods that we use when standardizing mortality and fertility data. Why is it important? As I said earlier on, standardization is a procedure of dealing with um, uh, problems of removing uh, challenges that are related with composition of variables. If we say composition of variables in demography, we talk of variables that are critical, like mortality and fertility, so that we should be able to have clean data as we are using the data in context. So we have got the forms of standardizing data. Now, one major process that is used is we call it direct method of standardization. So we call it direct method, and at the same time we can call the other method the opposite, which is what? The indirect method. So normally there is a small streamline in these two methods. What is required is for us to understand the way we actually can be able to come up with the approach adopted to this. For example, we can have if you can check in table 6.1, we have got the age group, and we have got those in group 1 and those in group 2, and we have got the ratio. On this one, I want you to refer to the chapter which is talking, chapter 6, which is talking of which is talking about the standardization. So normally what you do is you must be able to establish the ratio, and this particular ratio you actually we can actually, let's say 20 to 24, we have got this, let's say like M1, and here we have got M2. So the ratio there can be obtained by M1 and M2. So at the end of the day, you're able to actually divide, and then you can say mi mk, and then this can be mi dot mk, so that in the long term you're able to determine the ratios. Now, having obtained this particular ratio, you can now be able to multiply them with a certain weight which can be given depending on the case, so that at the end of the day you're able to determine the values of importance in your standardized results. So on this particular point, I want you to actually look at a practical scenario which has been demonstrated in table 6.2. Now, in this table 6.2, if you can look at it, we have got number 1, 2, 3, 4, 5, where number 2 is population 1, is population 1, and number 2 is population 2. So we have got two population. Now in this case, we have got now number 1 as the age group, which is 0 to 4, and then we have got the population here, xy, and then we have got number 4, which is actually the standard population per 1,000, which is always given as the standard population per 1,000, which is given. Now, if you want to determine the expected mortality or expected dates, then you must be able to look at 2 multiplied by the standard population, which gives us number 5, and number 6 you can be able to look at the population number 3 multiplied by the standard population. And then when all is going to be said and done, what you normally do is you can be able to get the sum here, summation of population, expected population, and then you can be able even to get summation of expected population in population 2. This is population 1. And when you do that, if you want to get the standardized rate in one of the population, then you actually look at in population 1, you say the sum of expected population in 1 over an standardized total. So this is an standardized total. It can be P1 and this can be P2. So you can be able to divide by P1. So this is actually the standard value, the standardized rate. And then if you say population 2 rate, then it is going to be expected population 2 divided by standard and standardized population this. So you can multiply these two figures by a radix, which is always 1,000, so that you can get the values that can be required. So in the table that you are referring to in Pedeco, table 6.2, you can actually see that there is 22.70 in the first population and the 18.95 per 1,000 in the second population. And then you can now start comparing the two and then see as to which one is which in that particular context. So that's actually the process that can be associated with the data in that scenario. Now, looking again, we can actually have another process which is called an indirect process, which is on the table 6.3. On table 6.3, if you can look at that, you can actually look at an standardized population, which based on that particular table, you can actually see that the computation is a bit similar to the first one, only that when we have calculated and multiplied the standardized population with an expected standardized population with expected population, like on 5 and 6, you must be able to determine the crude death rate. Now, the crude death rate, you actually know that we actually get it by taking the total deaths that we have encountered divided by the total population, and then we multiply that one by radix. So in this particular case, since we have already been given, we were given that the total death rate is, the crude death rate is 18.55. So that's why you can see that in the subsequent tables, there is nothing on the ground, and then there is now an actual death in population 1 is 116,360, and actual death in population 2 is 113,170. Now, the total death now, from a standardized perspective, we have got 112,033 and 112,165. Now, looking at this particular part, you can now divide to get the ratio, which is actual death divided by expected death, which is 112 divided by 116 times 100, and the 122 divided by 113 times 100, then you get the corresponding values at the bottom. Now, in order to get the age standardized values, then you actually take the crude death rate multiplied by the ratio which you obtained. So you can actually see that in this case of table 6.3, the process is a bit complicated compared to the unstandardized process. So that is actually what we actually look at. Now I want you at your own time again to go and look at table 6.4, which is looking at computation of indirect standardization of general fertility rate. Now this is now not fertility, not mortality, but now we are looking at fertility. Now the standardized general fertility rate standardized general fertility rate is actually obtained by taking actual birth divided by expected birth multiplied by general fertility rate. And you can recall in the previous classes we are discussing about GFR, and then in order to get the actual birth from the table that we have, we can actually say that the value is 39,690. This is what we were given. And now the expected birth is the one that is obtained after multiplying the number of births that the women can give and the standard population rate, which is actually given. So the expected sum of that, which is 35,500, you divide into 39,690, and you multiply by general fertility rate. Remember, general fertility rate, it could be, in this case, 206.3. So if you have got 206.3, you can be able to multiply and then get the actual value, which in this case is 231.3 per 1,000 women. So at the end of the day, we are able to actually determine the values that can be associated with that. So the last part which I want us to look at is the process of determining what is actually referred to as the relationship between a direct and indirect standardization method, which we normally look at it from the lens of comparative mortality ratio. So I will be able to discuss on the comparative mortality ratio in the next section, so that we should be able to understand how it is applicable in context. That's the most important